Okay, now this is an last session of the permutations and combinations, and after so long we are ending up with the chapter. Obviously the chapter covers all 7 sessions, and then we'll have a DRS session and then next chapter. Okay, now what is exactly miscellaneous problems of combinations means with C now? Actually, all the applications of permutations and combinations have meaning in the JEE examinations. Means maybe in the state board pattern you will not get the question related to this. Okay, but for JEE it is a specially important session because permutations and combinations together. What are the applications? What are the examples commonly we can solve based on the two concepts that was asked in the miscellaneous problems? Okay, now everyone knows the use of combinations. So what is that? Unique ID creation. Yes, no? So any kind of password, any kind of mobile number is the great applications of permutations and combinations. So that I have put in the reflection. What are the uses of this? Obviously in the real life we can, real life connect is what, which is not a mathematical. Clear, mathematical is a conceptually, but mathematical use that or mathematical applications that we are going to see today. But what is the real life uses of permutations and combinations? These are some common examples like a combination lock, passwords, phone numbers, car plate number, playing video, piano, then word formation, ordering food, clothes combination, selecting teams. So if you see the left hand side is the permutations related with the permutations, clear? And this one is the right hand side applications are related with the combinations, clear? Okay, now just have a look on this in a 2 minutes, because many times you have to entitle this any of this for your any simple questions. Okay, so now next is content to recall. Everything in the chapter we need to recall today because this is the last chapter. Okay, so what is basically fundamental counting principles, permutations, under permutations, linear permutations, under linear permutations. Then we have a circular permutations, linear permutations cases are there like non-repeated, distinct, repeated, distinct, repeated, identical. Clear? Okay, these are permutation cases. In that important topic is the rank of word. Clear? Finding a rank of word, and sum of n numbers also we have covered. Then next is the combinations. In the combinations, addition, multiplication together is used to team making questions. At least 6 bowlers, at most 2 batsmen, or girls or boys. That is the combinations. Then properties of combinations. These are important things. Clear? Okay. Now, and the one more thing, Beggar's method is important in the combination. Okay. Beggar's method is truly important because we have the applications of Beggar's method today also. Okay. So what is the Beggar's method? Only Beggar's method we are revising in the recall part now. What is the Beggar's method? Anyone? If I have n objects, n identical objects, distributed in p kinds, right now? What is the formula for Baker method? N plus p minus 1, c p minus 1, right now? So n identical objects distributed in the p kinds of objects. This is known as a Beggar's method because Beggar's method is today useful. Okay, now what are today's learning concepts? Very important parts, and these all parts are carrying at least one example for JEE. Okay, so first one is the functional applications of permutations and combination, geometrical applications of P and C, sum of numbers based on P and C, divisibility of the numbers, involved in the permutations and combination, inclusion exclusion principle, D arrangements, number of integral solutions and factors of natural numbers. So today we have a total 10 applications. So what I done in today's session, one application, one question based on that, one application, one question based on that. So likewise we are going to solve 10 questions. Clear? Okay, so now let's start with the first one. Only formulas, formulas, formulas. So you have to remember these formulas for the particular cases. Now this is completely optional thing, but this is an extra benefit, or this will lead you to the extra benefits for the JEE. Obviously, if you get a JEE in the JEE functional kind of the question, functional application kind of the question, then obviously you have to remember that formula. Okay. Now let's understand. Now my methodology for you is read it line to line and ask me doubt from your end that ma'am please explain this formula. Getting clear? Okay, so now we'll reverse or flip the situation that always I am reading and explaining. So now the beneficial will be like you will read, you will understand, try to understand, and if still you are not getting, just tell me that ma'am please explain this one. Okay, and if it is done, then tell me done in the chat box so that we'll have a look on the next one. One more thing I need to explain over here. This notation is of combinations only. This is nothing but the NC1. So what is this one? NC2. Clear? Just tell me if it is done. Now you may not get the meaning of 1 on 2 functions. Or I have explained 1 on 2 function. No, it is actually in the syllabus of 12th. Okay. So what is 1 type of function? See, I'm just making you understand the two words which are completely new for you. So what is a function that we know? What is a function? Relations and functions. What is a function? Connection of A to B. Okay. But every relation is not a function. What are the cases that relation to be the function? First thing, all elements have of the A have pre-image, right? No. So these are the cases of the function. Then what it is called as a 1. Only A will have only one connection in the B. Clear? Okay, so situation like this is not acceptable. One element of A is connected with 2 or any 2 element is connected with the 1 in B. Getting point clear? So 1 is exactly one element of A is connected with the exactly one element of B. Clear? And what is onto? All elements are connected. When the all elements are connected with the 1 type, then it is known as the 1 function and onto function. Clear? Onto function cleared. Every element of A should have a connection with the element of B. Clear? Okay. Now, means these are the formulas. You will get it more deeply when you will done with your 12th. Clear? Okay. Now, proceeding ahead, the number of increasing or decreasing functions from A to B is directly NCM, where M is the less than N. The number of non-decreasing function will be M plus N minus M 1 upon M. The number of bijections from A to B is n factorial. This is an important bijections. Bijections is like onto function only. Okay. So then number of bijections from A to A. One set on itself only is showing this kind of bijections. Clear? Okay. The next one is direct a question which involves this kind of things. Now see, the number of functions f from 1 to 3 to 20 on to 1 to 3 to 20 such that f of k is a multiple of 3 and wherever k is a multiple of 4 is. Now, first thing you have to calculate the number of elements of f of k. What are the ordered pair which are following the number of 11? What is f of k? Can anyone tell me? Forget about this is the question of permutation and combinations. Just try to answer me that what is exactly f of x. See, f of k is the multiple of 3. That means it will have which number of sets? 3, 6, 9. Right? Okay. Clear? And what is the, I'm just taking k1 as function 2 and k2 is equal to what? What is the k2 function? Multiple of 4. So what is the answer? So first one is having how many elements? So 6 elements. Okay. And f of k2 is having how much elements? 5 elements. No doubt in this. Now let's understand the question. The number of functions from f to, the number of functions means bijections only. Got it? Clear? Number of functions is nothing but bijections is asked. So you need to answer for number of bijections. So what is a number of bijections? Number of bijections both are occurring. So it is nothing but 6 factorial into 5 factorial. Clear? Okay. Is there any set which is getting wrong? Number of functions from A to 20 on to on 1, 2, 3, 4, 5, 6, 7, 8. So it is 5 factorial into 6 factorial. Okay, got it. Clear? Now just pay attention. This is not a final answer, but this is a wrong answer. Why it is so? See. The number of functions from A to B is asked. Okay, so fine. A set to B set. How many functions are created? How many functions are created? 5 functions are created because A is having 5, B is having 5 elements. So obviously any 5 from the A will attach with the B. Clear? So function from A to B is 5 in a number, but now we are left with the C. So what will be the exact explanation? C. Function from set A to B is equal to how much? 5. Okay, clear? Now remaining how many elements? If I consider any set 1 to 20, 20 elements are there. N of A is equal to 20. Out of 25 are showing connections, bijections, function with B. Okay, so remaining count is important, no? 15 elements. Okay, So 5 elements will be connected with the bijections 5 factorial into, okay, 15 elements. So it is 15 factorial. Clear? Yes or no? Otherwise, into 6 is answer one more time, because we have any, see, A set is of 6 elements and B set is of 5 elements. I know it's not easy to understand, but now see why this 6 is come. Or you can explain this answer as either selection of, see, selection of combinations will be there 6C5 into 5P5 into remaining 15P15. Clear? So it will be 6 into 5 factorial into 15 factorial. Clear? So it is equal with 6 factorial into 15 factorial. Got it or not? Both the explanations are clear. Out of 6 elements, any 5 will be connected with the other element, right? So that can be done in 6C5, because that is a combination, right? Selection is there, no arrangement is there. So one from A, one from B is the selection, right? It's like a team only. So it is 6C5, which is leading with answer 6. Clear? Remaining 5 elements can be arranged with the number of bijections method, that is 5 factorial. Clear? And remaining 15 elements can be arranged with the 15 factorial. Clear? Okay, so that will be the total answer. Hence our total answer is 6 factorial into 15 factorial. Answer A is correct. Yes or no? Got it or not? Explanation is cleared? Yes. Okay. Now moving to next, it's a very simple part. Geometrical applications will directly give you answer in your state entrance also. Okay. Geometrical application means what? Forming and straight line, forming and diagonal, forming and triangle. Clear? So let's read it one by one. Out of n, obviously we are done with this shortcut in the last lecture also. Yes, no? Diagonals question was done, no? 2 diagonals question I have taken in the combination session, but still have a look on this formula list. Out of n non-concurrent and non-parallel straight line. Non-concurrent means what? Not lying on one another. Okay, not concurrent. Okay, so out of n non-concurrent and non-parallel straight line, the number of points of intersections are always equal with nc2. The number of straight line passing through n points are nc2. The number of straight line passing through n points, out of which m are collinear, will be nc2 minus mc2 plus 1. Direct shortcuts are produced. Okay, in the polygon, total number of diagonals are the n points, that is nc2 minus n, that we have done in the last part. Number of triangles is nc3. Clear? Out of n point, any 3 will connect for a triangle. Okay, then number of triangles formed by n point, out of which m are collinear. Directly m points are already collinear, then nc3 minus mc3. Clear? The number of parallelogram of two system of parallel lines when first contains m parallel lines, second contains n parallel lines, is nc2 into mc2, and directly remember this as in shortcut. The number of rectangle of size of squares n cross n is summation of r running from 1 to n r cube and summation of r running from n square. Number of squares will be like, you have this puzzle. Have you done with this puzzle at any instance of your life, that some of the things are given like this and count the number of rectangles? You are done with this puzzle, this kind of puzzle? Count the number of rectangles or squares. Directly this kind of the things will be solved with the permutation. See how now I'm doing over here. What is the application of last formula? See, the number of rectangles of any square of n cross n. Okay, so how many squares are there? N, 1, 2, 3. So square is required. Fine. So square is required. So it is 3 cross 3. Here n is equal to 3, right? No. So here n is equal to 3. Okay, fine. So r running from 1 to n, r running from 1 to n. Now see what is this summation. Okay, I'll first make you understand with the summations. Okay, because in one of the question also we required a summation solving. Okay, we'll solve this one. But write down in your notebook. Obviously in the next chapter only we are going across this, but now learn it. Summation symbol. Everyone write down in your notebook summation. Okay. Now see what is the summation is. If I add 1 plus 1 plus 1 plus dot 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 5 times, what will be the answer? What will be answer? Very easy. 1 plus 1 plus 1 5 times. What will be the answer? Please answer. It's a very, very, very easy. 5 times 1 answer. 1 plus 1 plus 1 plus 1 plus 1. 5. Okay. Then why you are thinking so much? 5 plus 5 is 5, no? Okay. So this is nothing but a summation of 1, where 1 is running from first to how much value? Fifth value, that is 5. Clear? Okay, so this is a symbolically representation of any kind of sum is the summation. Clear? Okay, so addition is nothing but a summation. What is the summation? It is nothing but the addition. Okay, clear? And it is denoted by the symbol. That symbol is known as sigma. Okay, now addition of is equal with 5. So the in general you have to remember these formulas. Addition of I running from 1 to n, okay, times of I is equal with n. First I'll take 1. Okay. Second is summation of I running from 1 to n of constant. What do you think? It is nothing but k into n. Clear? Okay. Then third one. Now see the addition, this one. 1 plus 2 plus 3 plus dot 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 or plus 4 plus 5 is equal to how much? What is this addition? Do this addition, perform this addition quickly. 15. Okay, now let's calculate it with the formula. See, Ri, the number R is starting from 1 to n. So it is n into n plus 1 by 2. So here n is 5. So here it is 5 into 5 plus 1 by 2, so 15. Clear? So this is a direct shortcut made for the summation value. Clear with example? Okay. Now, next one is fourth one formula. Write down summation of I running from 1 to n Ri square. Like if I want to take a addition of 1 square plus 2 square plus 3 square plus 4 square, do it for 4. Do this addition. What is the addition you are getting? 1 plus 4 plus. Is it you are getting 30? You are getting 30. Okay. So see, with formula also I solved and we got the addition 30. Clear? Okay. And similarly, just for cube, write down direct formula. I running from 1 to n, ri cube is equal to n square into n plus 1 whole square divided by 4. Just these 5 formulas are important for the summation. We have next pattern of formulas for the sequence and series also. But for timing, just remember like cubic, square and clear. Okay. So these are the 5 formulas of summation. So now in back to our question. See here, the number of rectangles of square size square r n cross n is summation of r cube from 1 to n. So what will be our answer for number of rectangles in this? It is summation of r running from 1 to 3 r cube. Clear? What is the formula of r cube? N square into n plus 1 square divided by 4. So I am just putting the value. 3 square is 9, 9 plus 1, 10 square is 100 divided by 4. So 25 into 9 will be the number of rectangles in this question. Clear? Okay. Direct with the permutation combinations and summation series, this formulas is developed. Okay. So now if you got the results like this, you can easily answer. Okay. And number of squares of any size squares is possible. Like any size means rectangle only. So that is n square. Clear? Okay. Now next is question based on this. Suppose that 20 pillars of the same height have been erected along the boundary of circular stadium. Okay. If the top of each pillar has connected by the beams with the top of all of the non-adjacent pillars, then the total number of beam sets. Try to understand which geometry is applicable over here. Read it again and I want this answer from you guys. See, there is in one circle, okay, a circular stadium is there. 20 pillars are there on the circular stadium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Clear? This is the geometry. 20 pillars of same are erected along the boundary of the circular stadium. If the top of each pillar has connected by beams with the top of all of its non-adjacent pillars. Okay. Like what is the non-adjacent pillars? I'm taking one for reference. If I'm taking this pillar, These are the adjacent. Okay, so it is forming this likewise any geometry. Getting clear? It is forming any kind of the geometry, but not with the adjacent one. Clear? Okay, so how many such pillars can be drawn? Anyone who can answer this? What will be? It's a very shortcut question. It's actually requires 5 seconds only. Please be quick with your answer. But how 170 is coming? Okay, 170 is fine, but can you please explain the geometry? It's nothing but, see, pay attention over here. It is a 20-sided polygon. And see, I'm taking a side. As it is not following this geometry, means we required only its diagonals. Clear? Okay. 20-sided polygon and its diagonals are required. Clear? Now what is the formula of diagonal calculation? In the last lecture only we are done with this. This is 20 C2 minus 20. Now if you could solve this one, 20 into 19 upon 2 minus 20. So 2 ones are 2 tens are. So it is 10 outside, 19 minus 2. So it is equal with 10 into 17, that is 170. I know after my, I am dealing with the explanations, you are able to solve. But I want you to solve before me, before I explain the question. Okay? Clear? Now, the answer is 170. Fine. So, my students are so talented. Now, see. Already we are done with this shortcut, if you are remembering. The sum of the n different digit numbers a1, a2, an. If digits are not repeated, then this is a geometry. Take a sum of all digits into n minus. How many numbers are asked? We are done with this in the properties of combination sessions only. Okay, clear? But still I am repeating this one. Now I want to form the number of digits sum formed with the digits 1, 2, 3. What you will do? If digits are not repeated, I am taking a first case. If digits are not repeated, what is the value of n over here? 3. Okay. And what is the sum? 1 plus 2 plus 3. So 3 plus 3 is equal to 6. Clear? Put in this formula. This is an extreme important formula. In that session also I have explained this formula only. So a1 plus a2 plus at. So I'm just putting in 6 into n minus 1 factorial. That is 2 factorial. Okay. That is sum of digits into n minus 1 factorial. Okay. We'll just take it in a highlighted manner. So what will be the answer? 6 into 2 factorial. That is 6 2s are 12. Clear? Okay. And the sum of total number of digits with the different digits a1, a2, a3, an, and again that repetition is allowed. If case B is there, what is the difference you are finding? N is not changing, sum is not changing, but formula is changing. So difference between the calculation is like 6 is there, fine, into 2 factorial is there, into how many digits number formed with the 3? It is 111, right? Okay, so it is n times, 1 is taken as n times, so it is 111. Clear? So if you could do this one, 12 into 111, what will be the answer? Now I have explained one shortcut to solve this example. Can anyone tell me? Anyone? I've already explained this. Okay. So what is that shortcut when you are multiplying any number 111? Then what you are supposed to do? It is nothing but with the shortcut I am writing over here. If anyone forget to multiply it, or just you don't want your mistakes in the multiplication, what you will do in the shortcut? It is nothing but the addition of 12. 3 times you are supposed to take it. Okay. 12 plus 120 plus 120 1200. So here it is 2331. Clear? Okay, so instead of multiplication you can do in the summation method also. Okay, because it's 111. This is a trick to multiply. Okay, got it? So let's solve very simple question, the sum of all 4 digits. Now you are so talented. Do it quickly. Now if the case is given, then it, in such case, if repetition is not expressed, then it is repetition is allowed. Clear? That is B case. What is the formula? Sum into n minus 1 factorial into 1111 n times. So now we take it. First thing, what is the sum? 1 plus 2 plus 4 plus 6 into 4 minus 3, that is 3 factorial to 1111 4 times. Okay. So what is answer? 10 plus 12 13 into 6 into 1111. So it is 78 into 1111. Got it? Everyone? So it's a numerical value question. So if you put here in your paper 86658, then you will get a non-negative complete score. Clear? Okay. So that's a really beneficial thing for us. Okay. Yes or no? Please have some smile on your faces. You are learning this chapter with lots of shortcuts. Okay. So I enjoyed no permutations and combinations. आता है नहीं आता है अलग बात. You enjoyed it while solving. When I was in your age, I'm just always enjoying to solve the combinations and permutations. Okay. Now, next one. Okay, what do you want a break? Should I continue? Okay, we'll take a break after 5 applications. We have total 10 applications. No? Let's list it out. 1, 2, 3. Third is done. After inclusion and exclusion principle, we'll take a break. Okay? Clear? So, next up application. Divisibility of number. Once in this sections only, permutations only, I given you the homework of checking the divisibility test of different numbers. And no one answered me. Okay. So see, this is a very basic but very important, and I know with the times you just lost it from your mind. Okay, so I'm just revising. What is the divisibility test of 2? Last digit is even. Okay, divisibility test of 3 is sum of digits whose digit sum is divisible by 3. 4 divisibility whose last 2 digits are divisible by 4. 5 divisibility either 0 or 5 is required in the final place. Okay. 6 is which is exactly divisible by 2 and 3 both. Okay. If you double the last digit and subtract it from the rest of the number, answer is multiple of 7 is the divisibility test of 7. Whose last 3 digits is divisible by 8 is the divisibility of 8. Sum of whose digits is divisible by 9 is the divisibility of 9. Whose last digit is only 0, it's the divisibility test of 10. Sum of say every second digit and then subtract the sum of all other digits wherever it is multiple of 11 and whose last digit is divisible by 25 is only 25. Clear? Okay, so these are the divisibility test you have to remember. Clear? And in JEE, any divisibility test is applicable. It's not like it's limited up to 2 and 3. It may be 11 also. Okay, so just remember this chart forever. Now, so with the divisibility test, we are done many types of questions in permutations only, but I have incorporated. So I'm expecting this answer. How many 4 digits number? It's a JEE advanced question, okay? How many 4 digit number can be made with the digits 0, 1, 2, 3, 4, 5, which are divisible by 3? And digits being unrepeated in the same number. So how many these will be divisible by 6? Okay, cleared? So first thing we have to take a total count. Okay, and then we have to take a, so what are the combinations possible out of these digits? Either case 1, see the total is equal to how much? 15. Okay, can you tell me another cases? We are taking divisible by 3. First we are taking divisible by 3. Can you tell me another cases? Please expecting cases from you. At least cases you can make. Okay, any other case? Done? Is there any other case comes in your mind? Now if I take 5, 1, 6, 7, 8, 9, 5, 1, 3, 0. 5, 1, 3, 0 is not included, no? 5, 1, 6, 7, 8, 9, 5, 1, 9, 3, and 0. 5, 1, 3, 0. Five one three zero case 6 3 0.
Ma'am, am I audible?
Okay, case 7 5142. I'll check this.
Ma'am, am I audible?
Yes, yes, yes.
Ma'am, I'm having a doubt, ma'am.
Yes, yes.
There is no 6 in the given digits, no, ma'am.
No, 6. We are taking divisibility of 6.
Okay, ma'am.
Okay.
2, 3, 4, and 6 means there is no 6 in the given.
Okay. Got it. We need to change that case. Okay, fine. So what is case 7? I am on the case 7. 5142. Okay, we'll do it if then it changes. Is there any other case? 3450. 3450 done, no? Acha yaar, 3450. Don't repeat the cases. 03012. 3012 done. 5142. Okay. Now first case is not acceptable as per Kanishka's opinion. Obviously it is not acceptable. So it will, I'll change over here. 1 and 5. Will erase any of the case 1, 2, 4, 5. Okay, case 7 we have to eliminate. Right, not? Now it's clear? Done?
Case 3 also having 0 to 4 6, ma'am.
Case 3 is also having 0 to 4, 6. So we need to change it. 0 will keep it 0, 3, 4, 5. Right? Now no repeating case. I think the question is wrong, but we'll solve. Let's check. Okay? 0, 3, 4, 5. Now done? So only 5 questions are eligible. Only 5 cases are eligible. Okay, done. Now, these are the divisibility of 3 valuable cases. Now, either case 1 will occur. See how we are going to answer. Total number of calculations, either case 1 will occur or case 2 will occur or case 3 will occur. So, whatever our final solution, that is a connective of or. Case 5. Okay, clear? Whatever is our solution, that will be the or is connective. So we are going to add the number of ways. This is clear? Case 1 or case 2 or case 3. Now let's talk about the next pattern. Digits are not being repeated. Okay, followed. The how many of these digits will be divisible by 6? Now we got here the digits which are divisible by 6, 3 only. So out of which how we are going to judge the digits divisible by 6? Under case 1, either 2 at I'm just solving for case 1, okay? Digits are 1, 2, 4, 5. So, last digit is fixed with 2 or last digits is fixed with 4. This is only divisible applicable for case 1. Clear? Okay. So, number of ways of creating this. So, how many chances to fill this bracket now? 2 is already fixed. So, these are 3 chances, 2 chances, 1 chances. Clear? Okay. So, it is equal with the 3 factorial ways. Got it? Clear? Okay. Similarly, here also it is equal with the 3 factorial ways. Okay. So, either this or this probability. Okay. So, it will be this and this will occur. So, answer will be 6 into 6. So, it is equal with 36 ways. Clear? There are total 36 numbers are generally clear now. Okay, because you need to, for 6 divisibility, you need to fix the even positions also. Okay, likewise, can you please generate the number of ways of the second, third, fourth cases? In this it is 36 only, no, 0, 2, so it is now. See, for the next one I am telling you, we'll have this snip for our reference. It's the same question. Pay attention over here. Now we are done with the number of ways of case 1. Now case 2, how you calculated case 1? It is not 216. Vishnu Priya, that's the main mistake, but I appreciate your answer. When you are applying logic. Now we are taking case 2, 0, 2, 3, 4. Case 2, 0, 2, 3, 4. What will be occur? The numbers having the 4 at its unit place and the numbers having the 2 at its unit place and the number having the 0 at its unit place. So you are simply saying 6 for this, 6 for this, 6 for this. That's why you are answering 216, right? No? But there is a matter when we are putting 2 at unit place, 0 will be maybe in the starting. No, that is not a 4-digit number. Clear? Whenever 0 is there, 0 can't take first position because we want a 4-digit number. Clear? Okay, so I'll give over explanation. These are 6 ways, fine. Okay, what about this one? This can be filled with either 0 or 3 or 4. So there are 3 ways to fill this. There are 2 ways to fill this. Okay, got it? Clear? Either you can do this in this way, otherwise you can do in that way also, like total number of ways. What are total number of ways? 6 ways minus the number of ways where 0 comes first. How many numbers are there where 0 comes first? I am fixing 0 also. Then 2 factorial ways will be minused. Got it or not? either 3 2 or sorry 3 4 or 4 3 will changing their position. So two numbers will be, 2 factorial ways will be minus. So it is 6 minus 2. So these are the 4 ways. Clear? Yes or no? Second explanation is cleared. Whenever there is in 0, there is a matter. Whatever is 0, there is a matter. Okay, so we can't take us 0 at first position. So total number of ways minus 0 at first position ways, that many numbers will be created. Now here 0 is at last position, fine. So this can be done with 4 into 3 into 2. So it is 3 into 2 into 1, that is 3 6 ways. So total number of ways for the case 2 is equal to 6 into 4 into 6. Got it? Clear? So 144 ways. Clear? Now case 3. Case 3 is again 144. This one is 36. This is 144. No, here it is only 0 and 4. 0 and 4. So here it is 0 and 4. 6. 6 for 0. 1 minute. 1 minute. 4 at unit place. 1 minute. Here there is a mistake. Again here 2 factorial ways will be minused, because the 0 can't comes in the first position. So total number of ways will be 4 into 4 into 6 ways. Clear? Case 2 is 96. Now case 3 is directly holding this and this. So 6 into 4, 24. Case 3 is directly 24. Yes or no? Getting 24? Please be with me guys. Yes or no? 0 at last place and 4 at last place. So I am just holding these two cases. 0 at last place, 4 at last place. So these are only availability for case 3. Now case 4, 0 at last place, 2 at last place. Doesn't matter, it's only 24. Clear? And case 5 is only 0 at last place. So 0 at last place means it is a 6 ways. Clear? So what are total number of ways? 36 plus 96 plus 24 plus 24 plus 4. Got it? Clear? Do it. (184). Clear? Understood? So whenever there is an OR connectivity, you need to understand that you have to add on the answers. Okay, clear? Should I proceed? The problems related with the creation of number you have to do in the same way. You have to make the number brackets, word brackets, okay? Word diagrams, and then fix the position of any number and then move your remaining number with respect to that. Clear? This is a shortcut to answer the number of digits numbers form. Now inclusion and exclusion principle. Have you seen this formula before? Have you seen this formula before? No? Yes, we have seen this formula in sets, no? First set of elements plus second set of elements minus set of their common elements. So this is known as exclusion principle only for permutations and combinations. Clear? Okay. Now let's solve the question. Now sometimes just remember this shortcut. Whenever you are, how many numbers up to 400, so I'm not taking 400, how many numbers up to 405 divisible by 2? This is a simple shortcut to remember, okay? Because many times the questions based on this will be asked. How many numbers are there by 405 up to 405 divisible by 2? Can you calculate? So I'll just tell you the simple trick. You have to take a greatest integer function of 405 divided by 2. Clear? So what is the divisibility of 405 with 2? It will be in a points only, right? No? So it is 202.5. So what is the greatest integer function of 202.5? I am making you to revise the set relation and function chapter. So 202.5 is lying in between which two values, 202 and 203. So we are taking a lowest part of that. That is a perfect integer of that is 202. So how many numbers forming with the up to 405 which is divisible by 2 is 202. Clear? You will remember this remark. Always this is an greatest integer function kind. Okay. Now, so you need to take one more thing. Whenever we are taking now here there is comes and or in the picture. When we are using the and when we are using or in terms of union and intersection, quickly in the chat box, please. When we are using and when we are using or. अगर किसी का रॉन्ग हो गया तो मैं यहाँ से आके मारूंगी आपको. And or is a connective for union and intersection for which patterns? See, when we are taking common things, that is we are telling like this thing like A and B set, right? No? So when there is a and connectivity, you have to take an intersection, and whenever there is a or connectivity, you have to take union. Clear? Okay. So now let's have a look on this question. The number of 3-digit numbers, total 3 digits number forming that are divisible by either 3 and 4 but not divisible by 48 is. Okay. Clear? Fine. So let's take a set A. Let's define the sets. What is a universal set? One minute, the question. Okay, the number of 3 digits that are divisible by 3 or 4. So what is the universal set over here? I'm just denoting universal set by X. 3 digits numbers. How many 3-digit numbers? Can anyone tell me with the logic? How many total 3 digits number do we have? Okay. out of which A set is divisible by 3, B set is divisible by 4. So A intersection B is divisible by 3 and 4. A union B is divisible by 3 or 4, and 48 is completely new set. Okay, so does anyone remember the table of 48? Calculate it. 48, how many cases? Just calculate N of C first. What is our required answer? See required numbers. What is the required answer? Pay attention. The number of 3-digit numbers that are divisible by 3 and 4 is the inclusion exclusion principle, but not divisible by 48. Okay. So divisible by 48 we need to subtract. So how many numbers, 3-digit numbers divisible by 48? Can you please tell me the C complement? What is the C complement set number of 48? 48 table you need to tell me. What is the table of 48 which holds the number, 3-digit number? So 48 threes are maybe 144, right? Okay. Then 48 fours are 192. Okay. Likewise you need to take. So 192 plus 48 will be next number. Clear? So it is 240. 240 plus 48 is the next number. It is 288. So 288 plus 48 is the next number. That is 336. Okay, clear? So how many numbers are creating? Can you please tell me the count? How I am doing is clear, no? We just found a first 3-digit number. All 3-digit number cover. Tell me the N of C dash. Number divisible by 48. I'm just writing a shortcut over here. How I calculated. Okay, how many cases you are finding or able to find out? See here, I'll make you understand the shortcut. See, either you can enlist all the 18 terms. This is an one straightforward method. Now pay attention for shortcut. How I merge these numbers. Say, pay attention on screen. I got 48 threes are 144. So I am just checking randomly that 48 into which number is coming first 4-digit number. Clear? Okay. So 48 into 21, I got the first 4-digit number which is not required. So 21st term minus third term, I got total 18 terms in between. Clear? Clear all the 3-digit numbers. Okay. Now we have to whatever the number of ways means what is our required number. This is our final solution that all values. What is the final solution? Number of A union B by inclusion exclusion principle minus number of C complement set. That is the 18 count we have to subtract. Clear? So that will get a number not divisible by 48. Clear? Now you will do it. Required number count is this much only. This is our final answer. Now, okay, fine. This is done. Now we need to take a counts. What is total 3-digit number? What is 3-digit number? Total 3-digit numbers. How I am calculating? See now, we have a 999, that is a 3-digit number, last 3-digit number, out of which 99 numbers are already 2-digit numbers. So total 3-digit number is 900. Getting it or not? So total 3-digit is number is 900. So 900 divided by 3 will give you the A data. 900 divided by 3, that is 300. What is the B data? 900 divided by 4, that is a 225. Okay, and what is the intersection divisible by 3 and 4? That is 12. $75. Okay, so what is the formula of N of A union B? N of A plus N of B minus N of A intersection B. Just do it, you will get your answer. So implies that $300 plus 225 minus 75, that is 450. So here we have the 450 minus 18. So our final solution is 432. Clear? Our final solution is 432. So the final answer is 432. Clear? Is there any doubt? See, if it is a question limited up to 3 and 4, you can directly apply inclusion and exclusion principle only. Okay? But extra added thing is not divisible by 48, which is C complement. So it is 432. Cleared? Okay? Yes? So take a 10 minutes break, then we'll start the next part, that is the D arrangements and number of solutions. Okay? Clear? Okay, fine. Hello everyone. Let's get back to the next solving part of D arrangements. Important applications are left over. Everybody please be on your places fast. This is actually JEE what is left in today's class, that is a multinomial theorem, that is a number of integral solutions, number of factors, that are the things left over. Everybody, extreme attention. Okay. What is de-arrangements? Opposite of arrangements. Opposite of permutations is the de-arrangement. Okay. Like, if I give you the question that what is the number of ways to post the five postcard in the wrong post offices, means what? Correct posting is the arrangement, right? No, but if the question in the question only wrong postings are given, that means everything is like reversed. Either it, if the A postcard is made for first post office, then nor in a but it will go in a B or C or D or E. Clear? So this is known as a de-arrangement. So de-arrangement is so simple to identify. When the exactly reverse of arrangement is asked in the question, you can guess that this is a question of de-arrangement. Clear? So what is this formula? This is a so complicated formula you are observing, but it is a very easy to remember. See, if and distinct objects are arranged in a row, then the number of in which they can be de-arranged so that it will not occupy its original position or place is n factorial into 1 minus 1 upon 1 factorial plus 1. Alternatively, 1 plus 2 plus minus is alternative, and hence the last is, we don't know, no, it is plus or minus if we are learning with respect to n. If n is even, last will be automatically minus plus. If n is odd, then last will be automatically minus. Clear? Okay. So it is, we have to move upon the number of factorials. Like if I have a 5 object, then we have to move upon 5 object. If we have a 4 object, then it will be run up to 4 objects. Clear? Okay, 4 factorial. So this is how you have to learn out the de-arrangement formulas. Now this is a formula that if r is lying between 0 to n, means there is an boundaries for the r from 0 to n. In equation is given, it is not exactly equal with n. Getting my point? If r is directly equal with n, that I have a 5 postcard and I want to post a 5 only. But I want to post maximum 5, means what? It will start from 0 to 5. Clear? At most 5 means what? 0 to 5. Clear? So this is a numbering change. So or we can say the change in the statement pattern. So this is an formula. D arrangement of n minus r is NCR into D of n minus r. So n minus r, if it is coming 3, then you have to move upon 3. If it is coming 2, you have to move up to 3. 2. Clear? Okay, so D arrangement values are very specific, and that will be asked for very lesser values actually. So because formula is so long, no? So either it will be asked for 1, 2, 3 or 4 or 5 max to max. So I'll just suggest that directly remember these formulas. This is coming from the that formula only. D arrangement of one object is 0. If I have a one object and I want to place that one object, then there is no chance to misplace, no? Clear? So 0 is answer. Then I have a 2 objects. Then what is the D arrangement number of ways? That is 1. Obviously, they will reverse. A will sweep with the first position or second position, and B will flip with the first position. Clear? Okay. Then next one is for 3, we have a total 2 number of ways. For 4, 9 number of ways. For 5, 44, and for 6. So now your thing is just tell me D7. In the next lecture, I'll ask this one because we don't have that much time. So with the D arrangement formula, D7 will be asked in the next lecture. Clear? But just remember this value as it is. Don't go in that hectic formula. N factorial into bracket 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial. Just remember this like an table only. How we are learning factorials is, you know, directly I told you to remember the formulas of factorial. Same I am telling you the shortcut to remember directly dearrangements. Okay, clear? Now this is the solution. If I go for the D5, what is the answer of D5? With the formula 5 factorial into so this is how the formula comes. So after solving you will surely get the answer 44. Okay, now fine, pay attention now. Ajay writes the letters to his 5 friends. Okay, so I have n is equal to 5 and addresses to the corresponding. The number of ways can the letters be placed in the envelope so that at least 2 of them are in the wrong envelopes. Now pay attention. There is not a thing like all are in the wrong envelopes. Clear? If all are in the wrong envelope, our hectic is so low in that. Directly 5 factorial will be dearrangements. Clear? Okay. But now at least 2 are in the wrong envelope. Clear? Okay. So can anyone give me the suggestion of answer? Isn't it following this formula? NC, but what is the formula? Now pay attention. If formula is from 0 to n, then only this is following. Clear? But now they are not telling that. At least condition is not applicable over here. Here the condition applicable is at most n. At most condition is applicable. Clear? So now I am reading the question. Ajay writes to his. Now what we can do here, better to do correct envelopes minus placing 0 in wrong envelope minus placing 1 wrong. Clear? Opposite cases I am considering. Either we can do this method. This is the first method, or second method is wrong envelopes minus placing 2 in wrong minus placing 3 in wrong minus placing 4 in wrong minus placing 5 wrong. Which one is easy? We can think on this question with the two method. Either opposite case will be considered all correct minus 0 wrong and 1 wrong. Okay. Otherwise the opposite cases all wrong minus only 2 wrong, only 3 wrong, only 4 wrong, only 5 wrong. Clear? Okay. So what you are feeling comfortable? First one is easy, no? Okay. If we think on this question, the first one is easy method. So with this method, just think on, if I want to place the 5 envelope at 5 correct places, it can be done in how many ways? 5p, 5 factorials. Clear? 5 envelopes at 5 different places will be done with the 5p, 5 factorials. Okay. If I want to place a 0 wrong on envelope, is there any way to place? Is there any way to place the 0 wrong envelope? Clear? Is there any way to place the 0 wrong envelope? Okay. So that will be 0 and only 1 wrong is only 1. So answer will be 5 factorial minus 0 minus 1. So it is 120 minus 1. So it is 119 weights. Clear? Okay, understood? So how logical question it is? Okay, so you can directly put your answer as 119. Now next one, number of integral solutions. Already I have explained this in a Beggars method. Number of positive integral solutions, number of negative integral solution, number of integral solutions in the questions. Okay, so see how it works. It's very simple. It is known as a multinomial theorem. In the next chapter also we have this multinomial theorem. Okay, have you come across the equation like this in the multinomial theorem, or the optional method for this is a Beggars method? So actually I am teaching this method to you just because you will not say that ma'am didn't teach us multinomial theorem, but there is no need to apply the multinomial theorem when we have a Beggars method with us. Okay, what is Beggars method? I have 5 coins distributed in 3 students. Clear? Okay. 5 coins distributed to 3 beggars, not students. I will not take students. I will take beggar. Okay. 5 coins distributed to 3 beggars. What is the method of solving? Anyone beggars method of solving? 5 coins distributed to 3 students. So what is the answer? N plus P minus 1 C P minus 1. So it is equal with simply 5 plus 3, 8 minus 1, that is 7 C2 will be answer. Clear? Solving is next part, but this one will be answer. Clear? Because this is an Beggars method. Either first one get 0, second one get 0, and all the 7s will be 5 will be distributed to third one. Okay? So this is a Beggars method. Now here the Beggars method comes. Here see, this is nothing but 5 identical coins. X1 plus X2 plus X3 plus X4 plus X5 is leading with 3. Clear? Okay, sorry. X1 plus X2 plus X3 is leading with the total number of coins, that is a 5. So this and this. Is there any similarity? Is there any similarity? This is a direct statement of Beggars theorem. Okay. Number of integral solutions or multinomial theorem is a direct statement of Beggars theorem. So I'll always suggest you that don't go in the application of multinomial theorem at all when you have a Beggars method with you. Okay, clear? Now I'll just read out this solution part. It is not that much required. See, what is the answer for this one? When you have a statement kind like this, x1 plus x2 plus x3 plus x4 plus xr up to xr is equal to n, you can directly get a x raised to n coefficient. This is an important formula for multinomial theorem. X raised to n coefficient is x1 minus x raised to power minus r is this one. Okay, but it is not required at all. Let's take an question first, then you will understand this. Total number of 3-digit numbers whose sum is 10. What is the answer? What will be answer if you think on this answer? X1 plus X2 plus X3 is required as 10. Okay. That means clear cut I have n is equal to 3. Sorry, n is equal to 10 and r is equal to or p is equal to 3. So what is by the Beggars method? 10 plus 3 minus 1 C 3 minus 1. So answer will be 10 plus 3, 13 minus 1, that is 12C2. Clear? Yes or no? Okay, clear? What is the answer? Okay, Achaya, you got the answer 54. How? Yes, your answer is in option and we got the answer of 66. Can you please explain why the beggars method is not applicable over here? So actually this question is incomplete question. Maybe at that time the bonus will be credited for this question. Okay. Now pay attention. If this question is given in the format that the total number of non-integral 3-digit numbers. Okay. I'm just changing this number. Okay. If the same question is there, but the question is asked for the non-integral 3-digit numbers. Okay. So non-integral 3-digit number is what? If it is specially asked for non-integral. I have explained this in the last lecture only. What is a non-integral required? Non-negative integral. Yes. What is a non-negative integral? We cannot consider the zero at all places. Okay. Non-negative means non-negative and only positive we have considered in the last part. Okay. So it is nothing but the case is x1 plus x2, or I just take it in a xyz. X plus y plus z is equal to 10, and the one more case is x is greater than equal to 1, y is greater than equal to 0, and z is greater than equal to 0. Clear? Okay. So now I'll change this question as changed as similar pattern will be following the beggars method. See, beggars method is applicable for identical objects. Okay. Here x is greater than 1, but y and z is greater than 0. So that are not identical. Clear? This is clear? So let's sort out that one first. So what is the answer? If I sort that one, that t plus 1 plus y plus z is equal to 10. Then my t plus y plus z is equal to 10 minus 1, that is 9. And here t, y, z are identical. Clear? Identical objects, identical kind of objects starting from 0. Clear? Okay. Now, if you see that objects are identical, so here t is lying between value of t is 0 is less than equal to t is less than equal to 8, and 0 is less than equal to y and z is less than equal to 9. Clear now? Okay. So what is application of beggars method over here? I am directly applied beggars method. 9 plus 3 minus 1 C3 minus 1 minus 1 case, that is T is equal to 9. What is the total answer? So 54 will be the total number of non-negative integral solutions. Clear? Clear? The methods are clear. If the anything is not specified, direct Beggar method is applicable. Clear? Non-negative, positive, 0, nothing is specified. Just we want addition as equal with 10. If this is a case, directly Beggar's method is applicable, which is leading with our answer, that is 66. Clear? So this question is the bonus question at that time. Okay. Now, if we take this question as a non-negative integral solution, then we are having this much as an answer. That is t is a new integer introduced, that is t plus y plus z is equal to 9, and hence Beggar's method is like this. Okay. One case we have to subtract where t is exactly equal with 9. I know this session is quite heavy to grasp because this is all application based session. Okay. But it is JEE only. Clear? Okay, now should I proceed? Here 3x plus y plus z is equal to 24. Now there is an again matter. So we have to consider this as an y plus z is equal to 24 minus 3 times of any constant. We'll take it, so take this solution for 24 minus 3k pattern. Clear? Okay. So what is an answer of y plus z? What are the values applicable for y and z? We want answer of, see, this 24, 0 is less than equal to 24 minus 3k is less than equal to 24. So lying between 0 to 24. So hence our k value. What is the value of k? What is the value of k? Solve this inequality and tell me the value of k. Now with this calculation, see, we are getting n value for the Beggar's method as 24 minus 3k, and p value division into the two parts only, y and z. So it is p value that is equal with 2. Clear? Okay, so what is the Beggar's method? Summation from 0 to 8. First calculate the Beggar's method, n plus p minus 1 c p minus 1. So it is nothing but 24 plus 3k, sorry, 24 minus 3k. Got it? Clear? Minute. 3k plus 2 minus 1 c 2 minus 1. So it is 24 plus 3k c 1. So which is equal with 24 plus 3k. Clear? So Beggar's method calculation for this one is leading with 24 plus 3k. Now, up to this is clear. If we eliminate the x, our solution of such kind of integral powers which come as 24 minus 3k. Clear? Okay. Now k is changing its value from 0 to 8. So what is, how to calculate k? Pay attention. summation of k is running from 0 to 8. Summation of k is running from 0 to 8, that is a 24 plus 3k. Okay, clear? So it is 24 plus 3 into 0 plus summation of k running from 1 to 8, 24 plus 3k. And if you apply the summation formulas, you will get the answer. Just solve it, you will get the answer. Twenty-four plus summation of 24 outside 1 to k running from 1 to 8 of 1 plus 3 outside summation of k running from 1 to 8 of k. So it is 24 plus 24 into 8 plus 3 times of k into k minus 1 by 2. Okay, so it is equal with 24 plus 24 into 8 plus 3 into 8 into 7 by 2. So what is the answer? Oh, sorry, it's minus 3k. There is a big mistake in writing. It's a minus 3k. So it's a 24 minus 3k. Solve it. You will get the answer. Try to solve and tell me answer. With the summation series, we are solving this question. 24 minus 3k. Here also it is minus 24 minus 3k. Just do it and tell me answer. We know already summation formulas. So I have applied these formulas over here. So it's a 24 minus 3k. What is total answer? 1 minute, 1 minute. It is in n plus 1. We need to take it n plus 1 by 2. Answer me, what is the answer you are receiving? 24 into 9. Okay, 81 is the correct answer for, just note down this answer. We'll cross check it in a next session if there isn't something wrong. Okay. Understood? Non-negative integral solutions. Believe in the last JEE examination 2023, such kind of integral solutions questions are 4 to 5 minimum in JEE 2023. See, I have incorporated these questions in this PPT only. See, pay attention on the self-practice questions, whatever we have. Number of ways of giving 20 district oranges to the 3 children. This is an beggar's method. 4-digit number, that is repetition is allowed. That is a case. And these all are JEE 2023 sums. Okay, clear? These all questions are from JEE 2000. Now, we are left with the factors of natural numbers. Okay, so we'll cover this part in the next session, because I know you will feel exerted with the all applications together. Clear? So what applications we have covered today? Which applications we have covered today in the summary, if you see? Functional applications of permutations and combinations, then geometrical applications, sum of numbers based on the permutations and combinations with the shortcut formula, divisibility of numbers, inclusion exclusion principle, dearrangements, and number of integral solutions. So number of integral solution, number of integral solution is having its another name as Beggar's method. You will find out this method in many of the books. Okay, clear? Now, number of factors is the only thing remained for this particular topic. We'll cover it in the DRS part. Okay, clear? So in the DRS first 30 minutes in the next session before, we will have the discussion over number of integral solutions, number of factors. Okay, clear?